off of. So yesterday we learned about. You mind getting that? Yesterday we learned about permutations, right? And you may have realized that you've been doing permutations all along. Okay, page 22. Permutation is just arrangements. How many different arrangements can you make? Okay. And I asked you to do fundamental counting principle, factorial notation, permutation. I would say these ones should have been flipped, because if you use the permutation notation and then you work it out using the formula, you end up with what we call the factorial notation. But I will tell you this, that most of the time, if you just go NPR, you put numbers in there and you go equals the number, right? Whatever it ends up working out to, that's all we need for most cases. Okay. So how many different ways can 9 soldiers stand in a queue? So for one, that's just when it comes to fundamental counting principle, we'd have 9, right? 3, 6, 9. So you go 9, 8, 7, 6, very tedious. Like that. Or you could say 9, right? 9, pick 9. Sorry, from the 9, you're going to pick all 9. And that ends up being 9 factorial over 9 minus 9 factorial, which is 9 factorial over 0 factorial. Do you remember what 0 factorial ends up being? It's always 1. So it's 9 factorial over 1, which is 9 factorial. So basically, what you did using the fundamental counting principle, right, comes back. So this is the factorial notation. This is permutation notation. Okay, perm. So in a sense, A is here. This would be B. This would be answering B right here. And this would be answering C right there. Okay. But I'm hoping that when you see this, you see 9 factorial anyways. Okay, that's what I'm hoping. Number 2, if you have 10 songs, and how many playlists of 6 different songs can you make? I will skip 2, 3, 4, 5, 6, right? And you've got 9 songs, so you've got 9 to fill the first spot. 8, 7, 6, 5, 4. Okay, that's what you get there. If you write that in factorial notation, you would go, 10, right? 10, 8, 7, 6, 5, my bad, because it's 10 songs. You fill in the 6 slots. Or you could say from the 10, pick 6. Okay, so normally I would just ask you to do that if you prefer to write it in that way. And remember, it's alpha window 7. Press option 7. So 10, pick 6. 151, 200 ways. Okay. Number 3, that's also a classic. How many ways could first place and second place be awarded to 20 different people? This is your first place, second place. Okay, so we've got 20 times 19, and let's assume that we're not repeating because we're grabbing from a bunch of people, right? And that'll be 20 times 19. I don't have the key in front of me right now, so 380, or 20, pick 2. Notice something. If you look up here, 10, pick 6, right? 6 slots. So that means, right, 10, 9, 8, 7, 6, 5. You start at 10, and you're going to fill in 6 slots as depicted here. 20, pick 2. You start with 20, and then go down to 19. There are 2 slots that you're filling, right? So you should see that relationship between the two. As I said, we're not doing anything new. We just have a different way to quickly answer questions, especially when they're big numbers. When you're talking 100, 1,000, pick, whatever, that's that. Just one reminder, if you were to go 2 pick 20, you would get the wrong, it just wouldn't work. As soon as this number is smaller than the second number, it's not going to work out. Oh, there it's 0. But most of the time it gives you a domain error. This one actually worked. Let's see, 18, pick 20, let's say. Oh, that's 0 as well. So for combinations, maybe. But you can tell that this isn't going to work for you, right? 2 pick 20, it's just not going to work. There's 0 options there for that. So that's another way of checking. Okay. Oops, sorry about that. How many people can 6 people occupy 4 vacant chairs? 6 pick 4. I'm just going to quickly do one of those. Okay. How many different 3-digit passwords? Notice that these are passwords. These are not numbers. Okay. Can you make, if you include 4 to 10, that's inclusive, right? If you're ever not sure, you go 10 minus 4. That's 6 values. But you got to include the numbers themselves if it says inclusive, right? So how many are we talking about here? 4 to 10? 7 options, right? So you kind of just add 1 and then you have got your 7 if it's inclusive. Otherwise, you're just finding the difference. So 7 options. If you have no restrictions, I'm going to ask you to add something here. The classic, how many have at least 1 repeated letter? Okay. So if there's no restrictions, I tend to go with the fundamental counting principle a lot more than pick, like permutation. Right? You can go that way, or you can go 7, pick 3. Oh, sorry, mistake. What's wrong with this? This is no repeats. Okay, this is no repeats. So I'm technically doing B here. 7 pick 3. You're doing B. When you're doing that, that's very important here to recognize. What's 7 pick? That would be 30 times 7, 210. This is B. Passwords. Let's do A next. A is different. You cannot use permutation when there are no restrictions, meaning you can repeat. So you've got 7 and 7 and another 7, right? You've got 7 every time. So how would you write this? You would write it like this: 7 to the power of 3. 7 to the power of 3. And what is that? 343? Passwords. First number is odd, and there are no repeats. Let's try to do fundamental counting principle and then rewrite it using permutation. So if it's odd, the only options you have here is 5, 7, and 9, right? Those are the only options you have. So 3. And you are not allowed to repeat anything. So from the 7 that you have, you're grabbing 1 to fill in this spot. You have 3 options, but you're only grabbing 1. So this should be 6, and this should be 5. Did that make sense? Okay. And so this is 30 times 3. So you've got 90, right? Passwords. How would you rewrite this? You could say, for this first one, you could say 3 pick 1 times 6 pick 2. So you can rewrite this like this. So if there's only ever, if you just want to fill in that first slot, you say, hey, from 3 you pick 1, and from the 6 remaining options you have, you pick 2. So that's how you can rewrite it. And every time it's 3 pick 1, you know the answer is 3. Like this part is 3. 6 pick 2, we know that that's 30. So you've got 90 passwords. Maybe on your study sheet, you'll add study sheet. I think I'm going to go back to the page, because you're going to flip through these pages when you're studying. One second here, it's the wrong booklet. The pages are a little off on this one. If you go to page 22, I'm just going to ask you to fill in if it's NP1, if it's NP1, so this number could be anything. You always end up with N. Okay? This is going to save you a lot of work. So if you need an example, 8 pick 1 is 8. Okay? 100 pick 1 is 100. That's what that is saying. So if you need to have that on your study sheet to quickly be able to do those, because I really wouldn't want you to press all these buttons, right? 8, alpha, window, 1. Like, it just wastes too much time. Okay. So if you're doing counting methods, on your study sheet, this is permutation. We're going to camp on permutation for a little while, and then we're going to switch over to combinations, where order doesn't matter. Right now, order does matter. All right. Hold on. I asked you, I was going to ask you to add something. D, can you just sneak in the D here somewhere? Whether you do it at the bottom of this page or whatever. How many passwords have at least one repeated, right? One repeated number. And the emphasis is going to lie on the at least one. On the at least one repeated number. So I'm going to do part D right here. How are we going to tackle that one? It would be extremely difficult, or the more options you have, the harder this gets. But one repeated would mean, right, that the first one and the second one repeat. The first one and the third one. The second one and the third one, or maybe all of them. So if you want to do every individual case, it's too much work. So we're going to just say total, no restriction, right? Minus no repeats. That's how you tackle that one. Sorry, I'm a little off there. So it's basically our answer in A, which was 7 to the power of 3 minus 7 pick 3. That was our B part. So we know that this is 343 minus 210, and that would be 133 passwords. So there's 133 passwords that would have at least one repeated digit in it. Okay. And we use indirect reasoning for that. So whenever you see the at least, can you maybe add this to your study sheet? That at least one, the at least one is the key word, if I ever ask you that, to do this. Okay? Take the total where there are no restrictions whatsoever, and then subtract. In this case, it would be the repeats, right? If it says at least one student from grade 12, that's coming later on, you would go total minus all the ones that have a grade 12 student, right? Or sorry, that have no grade 12 student, I meant to say. You want to take away the no's to end up with the rest, okay? So that's important. I think the rest I'm just going to leave for now. Maybe 23 part C, just so you can't say that I didn't cover this part right here. Part C. Sometimes you'll have to break a question into cases. Okay, so let's do question 9 on page 23 here. You must create a 5 to 7 letter password, no repeating letters. It's 27 for you? Sorry, guys. Yeah. That's what I get for constantly changing my booklets. 27 for you. I'm going to switch over to the new one, okay? There you go. Page 27. Thank you for telling me that, reminding me of that. So for question 9, if you did it, you know where this is going to go. Okay, so we've got 5 letters. You can go 1, 2, 3, 4, 5 if you'd like. So that would be, what are our options here? A letter. These are all letters. So you've got 26, 25, 24, 23, 22. Or we're going to go 26, pick 5. So this would be a password using 5 letters. If it's 6 letters, 1, 2, 3, 4, 5, 6. I'm going to skip to this part. Or 26, pick 6. If it's a 7 letter, it's 1, 2, 3, 4, 5, 6, 7. Or from the 26, pick 7. And remember, when we do pick or permutations, we're assuming no repeats. Okay. What now? The last step. Or. You got to add all of this up, right? And maybe I should first give you the answers here. And this is where using your calculator to your advantage is going to help you, right? So I'm going to go copy paste this one up here. And I'm just going to replace, I'm going to go 26, pick 5, make sure you delete the, so this one is 7893, 600. You copy paste it again, change the 5 to a 6. You copy paste it again, change the 6 to a 7. And you can tell that it grows rapidly the more. 33.1, 531, 2 followed by 3 zeros. So got to make sure with these calculators they don't have the commas. So it's a bit harder to figure that out. And then you just add them all. So that is 3 billion passwords. Question. What if I had made this password case sensitive, meaning capitals and lowercase letters are different? How many options would I start with? You've got 52. So you've got 26 lowercase and 26 uppercase. Combined is 52. So most of our passwords that we make are case sensitive, right? I would say all of them nowadays. And then on top of that, if you add special characters, right, let's say you add special characters and let's say there's 5 to choose from, you go 52 plus 5 is 57. Plus numbers, 0 to 9. 57 plus 10, 67. So technically you would go 67. So you just got to read very carefully what are my options. In this case, we're only letters. They didn't specify case sensitive, so we just assume 26. If they had mentioned repetition is allowed, or in fact, they don't even mention that repetition is not allowed, then we're going to assume it is allowed. Then how would this have changed? It would have been 26, 26, 26, right? It would have been 26 to the power of 26 to the power of 26 to the power of 7, and then you add all of that, it would have been astronomically big number, a really big number. Possibly not even, our calculator probably would have to go scientific notation at that point. There are times where I will deal with that scenario, but I won't ask you for a final answer. I will just ask you for the work here. Just set it up. What would it look like? What would it look like? And so I would expect you to show me the work up until this point, perhaps right here. What are you doing? What are you adding and whatnot? So these are the cases. And I think I asked you to stop there, I believe. I don't think I asked you to do this one, right? No, 28 I didn't, because we're going to look at that today. People sitting together, sitting right beside each other. You cannot separate people. So we're going to deal with grouping today, a little later. So let's pause here.